Alright, time for another Draftscience.com, debatephysics.com also, but nobody debates rationally. So it appears that Michael Falwell has actually playing one of my videos, which is good. Frankly, this one is so obvious in the point it's making that you don't need to play the whole video. You just need to play the pertinent part, which is the accusation that friction isn't linear. And when you roll something on a surface, it applies a different amount of energy goes into the ground depending on its speed. The fast thing bangs into the ground less, is pushed into the ground less, and the slower it goes, the more it's pushed into the ground, the more of its energy is lost to the ground. That's the contention. Now, I don't think he's stupid enough to think that isn't absolutely true. And so he's just playing word games here to deflect the facts, because he wants to lie and propagandize. He wants people to be fooled by the fact that something rolls 4 times the distance, when he knows, twice the speed, 4 times the rolling distance, when he knows why that actually happens, and he just doesn't care about that truth. Alright, so his first counter argument is somehow I don't have evidence. Now, Galileo proved this 500 years ago, and I think any idiot can understand the simple argument. You have a scale and you run something across the scale. You roll something. Scale is a little part of the rolling road. It's obvious that if there's a certain speed you go at where the object isn't going to be on the scale long enough for it to read its weight, it's going to get lighter and lighter, essentially, the faster and faster you move it across the scale, because gravity actually needs time to push it into the scale. If you don't give it any time to push it into the scale, it's not going to push the scale. Now, I think he knows the answer to that. I think he knows if he did that experiment, he knows exactly how it'll come out. And yet he's playing this game. Okay, so I'll play this little bit.
Making a claim.
Alright, more volume.
You're not showing any evidence to support it. You just...
I don't have to, is my argument. Galileo proved all this stuff, the 1, 3, 5, 7 thing. A ramp can be of any slope. Galileo said ramp can be like this, it can be like this. It doesn't matter the slope of the ramp. So you can have a 0 slope ramp, and the same rules apply. So I don't need to do the experiment because, frankly, it has been done by physics. And most physicists don't want to talk about it because it's a truth not to their advantage. But, it is a truth. It's a fact. If you're going to claim it's not a fact, that's okay. Just do it honestly. Just say you don't believe it. Say you don't believe, the 1, 3, 5, 7 thing happens when something's rolling. That in when it's at a high velocity, it's losing less energy to the ground per foot, per inch, per unit of distance. Tell me you don't believe that's true. Just tell me that you think it is linear, that it loses the same exact amount of energy no matter how fast it goes, per inch. Tell me that's what you believe, and then I'll provide you evidence. But I don't think you do believe that. I think you're a liar to pretend you believe that, because I don't think you're that dumb. That's the frank truth. I don't think you're stupid enough to think it isn't absolutely true that the faster you go, the less contact you have with the surface.
Drawing it on a board and saying it's so. Which isn't really very scientific, is it?
Right. The whole argument is because you claim it takes 25 times the fuel to go 5 times as fast. The whole argument exists because you're claiming, that it's 4 times the energy. That's your claim. You're saying the 4 times the distance represents, each unit of distance represents an amount of energy, and you're saying it's 4 units of energy because it's 4 units of distance. That's your claim that you haven't proven. You haven't shown ever, that it takes 4 times the energy to go twice as fast, or 9 times the energy to go 3 times as fast, or 16 times the energy to go 4 times as fast, or 25 times the energy to go 5 times as fast. You have 0 evidence defending your theory. 0. So don't talk to me about providing evidence. Where's your counter evidence? Where have you shown that as the ball rolls, it reaches half its velocity at half the distance? Where have you shown that it is linear? Where have you done that experiment? Oh, that's right, you haven't. faker, phony, fraud. Alright, so I'll play some more, see if he makes another argument of some kind. I'm assuming this is going to be the only argument he makes for 35 minutes, but we'll see. Well, his speech is rather garbled, but I think he's saying you can't scientifically test these things. Obviously, it's easy to test.
It is not evidence. Yeah. So, like I say, we probably can test this out.
We probably can, he says. Yeah, so why haven't you? I mean, you've only had the 500 years since Galileo. You're saying Galileo's experiments aren't good enough. So why hasn't somebody else done it? I'm sure Newton did it. I mean, I'm sure Newton knows that pendulums slow down, more time at the end than it takes to do the swinging part at the high velocity. I'm sure Newton is perfectly aware of the 1-3-5 thing.
This is the thing, you're claiming it, but you can't scientifically test these things.
Oh, so what do you mean I can't test them? Again, first off, why would it be my job to test them? You're making this assertion that it takes 4 times the fuel, and you're saying this is evidence that it takes 4 times the fuel. You're saying because it's going twice as fast and it covered 4 times the distance, that means it has 4 times the energy. That's your logic. Well, where have you demonstrated with any evidence? Where did you crash it into something and show it does 4 times the damage? Where did you show that? Well, that's right, you didn't show any of that. And the evidence that does exist points in the opposite direction. All the crash tests aren't showing this exponential growth, this quadratic growth in destructive impact. It's not a fact that you've demonstrated, or you've proven, or you have any evidence to prove. You faker. Alright, so it won't play what he just said, but it doesn't make any sense. He says it's not a fair comparison to give something twice the velocity and see how far they roll. Obviously, I'm saying it's not a fair comparison because, yes, friction is not linear, so the thing going faster is going to incur less friction per foot, and that's just a fact. But how is it unfair otherwise? I mean, he just says it's unfair. What way? It's a fair way to test. It's just insane. Well, anyway, so that counter-argument doesn't seem to mean anything. How else do you test it except to measure how far it goes and to measure what speed it's going when it's traveling? I mean, you're saying that it's somehow difficult to take the time, the velocity, and how fast something slows down? That's not hard to do. Alright, so I made the point that the friction, rolling friction, is friction created by gravity. The friction is only maintained because gravity provides a force. If there's no gravity, it's just like dropping something next to a surface. It wouldn't make any difference. The surface wouldn't slow it down because there's no force pushing the object into the surface, so the friction would be non-existent. He didn't understand that point and just said, well, everywhere on Earth there's gravity. Well, that's not the point. The point is if I have the surface this way and I drop it right next to the road isn't going to provide any friction. The road only provides friction because you're pushing the object into the road. Huge, giant difference. Completely ignored. Alright, so he adds to that by saying he doesn't know where I'm going with that one. Oh, shit. You can't see. Yeah. My bad. Alright, sometime later, I'm back. Yeah, so there is the image. Okay. And you can see the part he's playing in the video, I'm explaining the gravity is pushing down. You can see little arrows pointing down. Okay. And so he's saying he doesn't see where I'm going with that. That, yes, I could do the experiment in some other direction and gravity would be irrelevant. So I could make a catapult or a lever and I could shoot things into gravity, and then you have to calculate for all the circumstances that gravity creates, or you can do it sideways and then gravity's not relevant. So he doesn't understand that some things on Earth are affected by gravity, some events, and some events aren't affected by the gravity. Even that has to be explained. Alright, so I will see if I'll see what his next point is. I mean, the point is this is a really simple argument. Either you're saying you sincerely don't understand how the friction isn't linear. That is, that the faster it's going, the less contact it has per foot with the surface, and it therefore will lose less of its momentum to the surface. you don't understand that argument. And your argument, your requirement is to provide some counter evidence that the friction is in fact linear, that every foot of contact, no matter the speed, is draining the same amount of energy from an object. That's your obligation. So, well, whatever. Doesn't even understand how argument's supposed to work. But no surprise there. I mean, you can't use arguments, against somebody that you're guilty of, so to speak. You can't claim somebody else doesn't have evidence when you don't have evidence. That's hypocrisy. I should just play it because he just makes a stupid statement. Every statement is stupid. So I'll play this little piece. I mean, he doesn't even understand the experiment.
Improve the contact. The faster you go, the less contact you have with the surface. So you're losing less per foot.
Right, the faster you go, the less contact you have with the surface. You really got to think about what you're saying there. Because if you're not contacting the surface, you're not accelerating. You can't. Friction, you need friction to go faster to accelerate. I mean, have you ever seen a Formula One?
Okay, so I mean, these are objects that already have velocity. The argument, you already gave them velocity. They already went down a hill. They have their maximum velocity. This is after they have their maximum velocity. We're talking about how long it takes them to run out of energy. There is no need for them to have friction with the surface to gain traction, okay? They don't need it. They're trying to frankly avoid it. You could argue the objects aren't really interested in slowing down, but they're forced to because gravity forces them to contact the surface. The contact with the surface steals their momentum. It's that simple. You might as well think of the object as a bowling ball. You've released it onto the alley. If the alley is lumpy and bumpy, you're going to lose your energy before you get to the pins. Duh. I mean, come on. You can't be this stupid. Well, like I said, I could play the whole everything he says. So he says you're making a claim there's more weight and there's more friction. So I just explained how, yes, it's the same amount of friction in this little section. The part going from 10 miles an hour to 0 miles an hour is per square inch of surface. You're losing the same amount of energy as you lost over 3 times that surface. That's Galileo. Again, I mean, it's 500 years old. All right, the fact that this happens, and you're pretending I have to defend a 500-year-old fact proven by Galileo. Oh, okay.
How are you demonstrating this? Apart from drawing a picture.
Because you're moving slower per foot, so that means you're losing land.
All right, so there's no argument there. I'm demonstrating by arguing it, okay? Where are you demonstrating the opposite? So there's absolutely no point in you saying, how have you demonstrated it? You've had 500 years of physics to demonstrate something. You've been making all kinds of assertions in physics. You claim these things. Why don't you have to prove any of them with evidence? Fuck. And then one of the claims you're making is that you're attempting to deceive little kids and people by saying, oh, look, it went 4 times further, and it's because it has 4 times the energy. When, no, you didn't prove it has 4 times the energy. You didn't show how it did 4 times the actual work. All you're saying is see, watch this fake. Be fooled. And you're being fooled. I mean, you know the truth, that the fact is that the gravity is pushing down on the object. Obviously, the amount of time the object's being pushed down is how much pressure it creates. Obviously, in the first 3 units of distance, it's the same time as in the last 1/4 of the distance. Those times are the same. If it takes 1 second to do that last quarter, then it's going to take 3 seconds. It's going to take 1 second to do those 3 units of distance. Those 2 times will be the same. The 3 units of distance will be the same amount of time as the 1 unit of distance. You know that's true. Oh, this is just... All right, so we'll play him. So I just made the Galileo argument. He says I'm making a claim.
It's not evidence, but you're making a claim to the contrary with no evidence.
Slower and slower, more and more energy is pulled out. So I control these lines a little more accurately by starting to start off faster.
So he's just going to keep, as I predicted, right? I mean, the video is just going to be him pretending I have to prove it, when, again, Galileo already proved it. And somehow he doesn't have to prove the contrary. He doesn't have to show any evidence of the fact that the friction is linear. He doesn't have to show that the same heat is in the ground where the 3/4 of the contact happen versus the 1/4. I'm saying if he does that experiment, he'll find there's the same heat in those two surfaces. The fact is, the 3 times the surface is just as hot as just the 1 unit of surface. And he doesn't have any evidence to dispute it. 0. But he's somehow claiming he can make claims and not prove them. Other people can't make claims unless they have some sort of proof. And again, I'm going to argue the proof is Galileo did the experiments hundreds of times. So I'd say it's a pretty good proof. I just can't I can't believe how stupid he is. Alright, now, my bad. I didn't think it was this stupid. So I point out in this section, I say this is going to happen in gravity. So if you want to create friction that's not gravity based, then it can be linear. And he's mocking that, saying there is no such thing. You have to make an anti-gravity machine. So if I simply did put bowling pins in the way, if I put any object in the way that frankly isn't going to be fundamentally controlled by gravity, any kind of rubbing force, okay, that isn't using gravity to create the pressure or the weight, I just make it go through a channel. And the channel, I can make the channel a little narrower or a little wider, so a little more of the fibers rub against the object. I can create friction in lots of ways that aren't gravity dependent. So he doesn't even have the imagination to understand that.
Gravity, and again, the fact that it's half the speed here instead of here in the middle is what demonstrates that it's doing the same thing gravity does. So you have to use some other kind of friction that isn't gravity dependent if you want to fairly.
Right, some other type of friction that isn't gravity based. Right, I'll just build an anti-gravity unit and try that out. What the hell are you talking about?
So again, he can't even imagine that you can create some other frictional force that isn't gravity dependent, that isn't gravity pushing something into something. There's no such thing as horizontal friction. There's no such thing as air resistance, and no such thing as water resistance. No such thing that isn't controlled by gravity. Of course there is. Ugh, dumbass. Alright, so now he's starting to laugh, so let's see what he's laughing about.
Clear as fucking mud, that. Like I say, we can test this out. You're just making a claim here, you're just drawing on your board, saying it works this way. You're not no evidence to support your claim, no experimental evidence, just.
Okay, so that's all he's going to say in the whole video. So he has no evidence. No evidence that twice the velocity does 4 times the damage to anything, or that it takes 4 times the energy to go twice as fast. No evidence that to go 3 times as fast you have to use 9 times the fuel, and that it does, just going 3 times faster, that it does 9 times the damage, that it's 9 times the energy. And the evidence does point exactly in the opposite direction. I mean, the Mythbusters did crash real cars at 50 miles an hour and 100 miles an hour, and there was no quadratic difference in the crushing of the cars. They 2 to 1. So you're just full of shit to say that there's no evidence, and to say that you have any evidence on your side at all. Ugh, pathetic liar. Alright, so here I do the scale analogy. I mean, I show the scale and make the point, and he basically just says, yeah, that's the point you're making.
Pull it out differently depending on how fast it's moving. It's as simple as this scale, and you can just logically understand the faster you go across the scale, the less you're going to weigh, and the slower you go, the more likely it is you'll weigh your full weight. So as soon as you go fast enough, where you're going to weigh something less than your actual weight, you'll get less and less.
Right, so all I can surmise from what you're trying to claim is that faster, lighter objects incur less friction than heavier, slower moving objects. I think that's the crux of your argument.
Right. So where's your counter argument to it? Where's your statement that no, that's not true? And Newton was a fool not to see your theory. And Galileo was fooled because he didn't understand that no, that isn't true. Where's your counter argument? All right, so he finished the video, the 5-minute video. So he's now going to draw it really badly, which is funny. But anyway, it's okay. It's better than nothing, and so good. All right, so we got the substance. The 3/4 of the video is going to be him explaining, I hope. Now the experiment is so dirt simple. I mean, the Dispar lab guy has 2 timing gates. I mean, obviously the physicist Michael guy has 2 timing gates. They can do the experiment really easy. Okay, just push something and then check and see it. Put one of the gates at 3/4 of the average distance that the thing rolls, and just see if there's the half the velocity. Not at all difficult.
Obviously, with it being a rolling argument and how much friction these things incur, I think it'd be a good idea to use a wheel cart, low friction, keep it quite substantial. So have the cart weigh 2 kilograms, add a further 2 kilograms. So the heavy cart's 4 kilograms. We can then, send that cart on its merry way at a speed, and then we can reduce the weight by half, so half as massive cart, and see how that fares when we launch that. But in your video you said it doesn't matter whether it's momentum or kinetic energy. Well, that's a good...
Look, I'm just making it as a throwaway line. I'm saying that we know whatever the substance is of this energy thing, the argument is that it's going to have half of it, okay, as found out by this velocity, all right, 3/4 down the track. I mean, so I don't care whether you call it kinetic energy or you call it momentum. The fact is it's only going to have half of it after it went 3/4 of the distance. That's going to be a fact.
Good thing, because we're trying to measure how much energy is taken out of the system due to friction. If friction is linear, will it draw the friction out? Will it draw the energy out through friction at the same rate? So say we launch the heavy cart, the 4 kilogram cart, and that goes, let's say, 10 mile an hour. And then we would say, well, reduce the weight, and take it down to 2 kilograms, and obviously we want to make it go faster. So if we said,
you could use 2 carts that
the lighter.
I don't know why this mouse sucks. Anyway, you can use 2 that weigh the same. It doesn't matter. It's half the velocity. You're just saying you don't need to make it half the weight. You're just saying, well, let's push one car at half the velocity. Now, weight has the same effect as velocity. The heavier something is, the more friction, the faster it loses its velocity. So there's 2 arguments. There's one argument saying, well, if the thing is heavier, it's going to lose its momentum quicker because it's hitting the ground harder. And if it's going faster, that can also, if it's going slower is just like being too heavy. And those 2 forces are at play, but you don't need to change the weights and the velocity. You can just change one of them or the other one. The fact is, if you take a half mass at the same velocity as a full mass, the half mass will end up going 4 times as far because the half mass is pushing into the ground half as much.
One go twice the speed, then we've got a bit of a problem there, because yes, the momentums would be the same, but the energies would be different. So to propel this 4 kilogram cart at 10 miles an hour takes an amount of energy, but if we wanted to propel the 2 kilogram cart at twice the speed, we would have to
So this has nothing to do with the video. The video is an argument about how friction takes away the energy. This isn't about how to get to a velocity. It's already stated what the velocities are. One is going twice as fast. The experiment I illustrated is just an experiment where you have 2 things that weigh the same, and you're just giving one twice the velocity. That's all you're doing.
Add more energy for that to happen. So if we were to test that under those conditions, obviously the 2 kilogram cart at twice the speed has received more energy to start with. So if we were to be testing for energy, clearly this one is 2 kilogram cars at 20 mile an hour would have an advantage because we've had to put more energy into that to get that to the same momentum. So that would be not a fair test because.
So again, you're just trying to figure out the linear, whether it's linear. So you don't even need to test it against something else. You can just take one object and you just roll it down a hill, get a constant velocity, watch it roll, and see where it averages, and put the timing gate at 3/4 of the distance, and then put a timing gate at half the distance. And Galileo's prediction is, okay, that at half the distance it's going to go more than half the velocity, and at 3/4 of the distance, that's where it'll go half the velocity, because friction isn't linear.
Clearly this one's more energetic, and
Gravitational friction isn't linear.
if we put more energy in to start with, we would obviously expect to see more energy out. So this would be an unfair test. So what we're looking at is we want a cart that's, we can reduce the weight obviously by half, we can make it lighter, but we want the same energy input into both.
Yeah, well, there's no point then, right? That's not what Maya was suggesting in the video. That's why I say it doesn't matter kinetic energy, because you're not doing that kind of strict comparison. You're not worried about a comparison, frankly. You're just arguing about how the energy will be taken by friction. And the simple argument is again, it's a Galilean argument, that the object will lose energy to friction based on its velocity. The higher its speed, the less it's going to lose. The lower its speed, the more it loses per inch of surface it rolls upon.
The best way I can see of doing that is obviously attaching a spring, launching it via a spring. So there's a set amount of energy going in, and then we take it.
So we already know that this is really unreliable, because you're claiming, okay, that 0.4 extra velocity is twice the energy. So I take a half mass, the 2 kilograms, I give it 0.4 more velocity than I give the 4 kilograms, and that's all I need to do to make its momentum, its let's just say its power, to be equal. Clearly it has less momentum, but you say it doesn't need momentum because it has more kinetic energy. It has the same amount of kinetic energy. So just going merely 0.4 turns the 2 kilograms into the same pressure or weight when it hits a surface. I say that's nonsense and rubbish and shit. Yeah, so let me see that. Let me see that done by a real professional experiment showing us that.
2 kilogram, take the weights out, launch 2 kilogram cart with the same spring. So each cart possesses the same amount of energy when it's launched, and therefore we've got an even keel there. We've got a heavy mass going slow, and we've got a lighter mass going faster, which I think
0.4 faster. Not much faster, frankly. And you say they'll roll the same distance, so I just give I don't know. Is that what you're saying? I don't even want to try to figure out 0.4 faster. I don't know the rules for 0.4 faster. The Galilean interpretation of 0.4 faster. It's just that every single thing you roll, so no matter how fast you roll it, no matter how much it weighs, every single thing does exactly the same thing, in the fact that it'll be 3/4 down the track when it's going half its velocity. So every single thing will follow that pattern. That's the assertion. It doesn't matter the slope of the ramp. 90 degrees, okay, it's almost no friction, so it's not going to work very well, but and then go all the way to 0 degrees, and the same rule applies.
Meets your criteria. What you're saying is a lighter, faster thing would incur less friction. So yes, it would only be roughly travelling at 1.4 times faster. But that is still faster, and obviously it's half of the weight. So I think, that meets the criteria of a heavy mass moving slow.
So again, he's conceding that isn't going to be the same momentum. So I'm going to give two objects very different momentums, and claim they're going to do the same thing. Well, they're not. But whatever. All of this shouldn't be in the argument because it's not necessary. The argument's a pretty simple one. Either you understand that gravity is pushing down per millisecond. It happens all the time and constantly. And the fact is that it adds up. The amount of time it has to push on something, that adds up. So the scale argument's the argument, the one you totally ignored and just slid right past. I mean, I can't believe you're too stupid to understand that, yes, the faster I move something across a surface, the less pressure it puts on the surface. I can't believe you don't understand that. The less the surface knows something rolled across it. A 10-ton truck weighs less on a piece of asphalt the faster the wheel can move across that surface. The faster the wheel moves, the less the truck weighs, according to that 1 meter of asphalt.
And lighter mass moving faster.
This is like running across a rickety bridge or something. I mean, you can't change your mass from the two ends, but you can certainly change how much you weigh to the boards themselves by getting across them as quickly as possible.
Like I say, we've got the same amount of energy in both. So therefore, when we are looking at that energy being, drawn out due to friction, if there's the same energy in, then when we look at how the energy is taken away from both objects, it's a fair test because they both have the same energy to start with. And that will give us a good indication of whether or not there is energy being lost due to friction for a slower, heavier moving object, or there's inversely a lighter, faster object included.
The simple argument is twice the velocity. So again, you wanted to pretend there was some other comparison being made in the video, and the only point the other object was in there for was the simple argument that at one velocity it only goes 1/4 the distance. So it was just illustrating the gravity argument. You drop the same weight from one distance, and then you drop the same weight from 4 distances, and it's only twice the velocity. It's only twice the amount of time falling, and it only weighs twice as much. So that's the point of the argument, and you're just deflecting all of that for contriving an experiment where you're going to make something go a lot slower than even, it's not even 0.5 as fast, it's only 0.4 as fast. So you're way far away from twice as fast, twice the velocity. So you clearly can't do the comparison I'm talking about. If you're not going to go twice the velocity, then that's the same thing as saying I'm going to drop at something other than from 4 times as high. You're not doing the comparison then. You're not going to see the 1-3 thing being comparable in the two objects because you've changed the whole units of time. You're not giving it 2 seconds on one side and 1 second on the other side. If you don't give it 2 seconds of time to fall in the gravity, it's not going to be going 19.6 meters per second, so to speak. Continuing.
It's less friction, so either way we should see some sort of discrepancy in how the energy's removed from both of these when they're launched. So just to clarify in terms of momentum and kinetic energy, just say this is a 2 kilogram cart and this is a 4 kilogram cart, and we need to put some energy in to make these things move. So if we were to put, say, that amount of energy into the 4 kilogram cart and that made it go 10 miles per hour, and we put the same amount of energy into this one, this will only go.
So that's the part where he got it wrong, okay? So Yeah. So he's going to put the same energy, kinetic energy. He's saying, and he's going to say that it's only 1.4 the velocity, which means they don't have the same momentum. So they don't have equal momentums, and yet he's going to claim they'll do the same work.
1.4, which would be 14 miles an hour, not the 20. If we wanted it to go 20, we would have to put more energy in, and obviously there you can see that if we put more energy in, then we would expect to get, if we were, say, these were cups of water and you were pouring them out at the same rate, obviously this one, to go 20 miles an hour, has more energy to start with, and so if we were to pour them, these both out at the same rate, obviously this faster, lighter one at 20 mile an hour would have,
so it doesn't
would
change.
Go further, would go faster, would have more energy.
So it doesn't change anything. Like I said, you run both of them on a track, it's still going to be 3 units of distance, then it goes half its velocity for the last unit of distance. There's still going to be 4 units of distance, and one of them, the same amount of energy is going to be lost as in the other 3 put together. You're not going to change that fact. You're not going to prove the linearity of friction with this experiment, because they don't have the same energy. They don't have the same momentum.
So therefore we would expect to see it on the way out. So the reason I'm suggesting we look in terms of energy is because we're keeping the amount that we put in to the system for both cards the same, and therefore when we try to, draw this energy out and see how that works, that we've got an even amount of energy in both.
I don't even know what his prediction is. So his prediction is if I make it go 1.4 faster, okay, and I cut its mass in half, is his argument still that it's going to go exactly the same distance as the twice as heavy object going 10 miles an hour? I'm going to argue it's still going to go further because it's lighter. The fact that you didn't give it as much energy isn't going to be enough of a deficit, okay, to the fact that it is twice as light.
Objects, and therefore if we draw it out, we can, we've got a proper level playing field type of thing, is what they say. I don't know. But it's a more, it's a fair test where, like I say, if we go with momentum, we've clearly got to put more energy in.
Okay, so I'm just going to say, look, the fair test is just take the same exact object, okay, and give it half the velocity and give it a full velocity, a 1 velocity and a 2 velocity. There, same object. You don't have any, no complications. Done.
To this one.
I mean, you already know what the result's going to be. It's going to roll 4 times as fast. The only thing you want to find out is, in the last quarter, did this one do exactly what that one did in its whole lifetime? The 1/2 velocity is going to go a certain distance. Well, the fact is the other one's going to do exactly that in the same amount of time. It's going to reach half its velocity and lose its velocity. It's going 20. It's going to go eventually reach 10 miles an hour. That's what the other one started at, was 10 miles an hour. The 10 mile an hour point is going to be 3/4 down the track.
Get it to go twice the speed to happen, whatever say momentum, but momentum isn't energy. You need to put energy in to give something momentum. They are different things, whether you want to believe it or not, they are. So
says you. I don't think you have any special knowledge for this at all. You don't have any collection of evidence for this. You don't give me any reason why you believe. Why do you believe that? Could you explain to me why you believe energy is something other than momentum? Why was Newton wrong? What experiment did Newton not pay attention to? So we know Newton did all these pendulum experiments, did all kinds of experiments. What wasn't he paying attention to when he overtly asserted and defended for the whole end of it till the end of his life that no, twice the force, twice the velocity, 3 times the force, 3 times the velocity? You didn't believe what you believe. Why don't you explain to me why Newton was dumber than you? What insight you have? What experiment you saw that Newton didn't see? Show me that experiment.
Like I say, in your video, you did say, as long as we put something in, whether it's momentum or kinetic energy, and like I say, we're trying to draw out the energy due to friction, so it makes sense to put the same energy into both carts, launch them, and see what happens. Right, so we've got his carts, and we're going to launch them with us.
So again, that wasn't what I described in the video. The carts were the same mass in the video, so you didn't even quite get that part. The argument was strictly about the fact that twice the velocity creates 4 times the distance. I didn't even use a lighter object. It's the same mass object.
Right, so same energy in, and see how much we get out. Obviously, the lighter cart with the same energy being put in is going to go a faster speed. So just say that one's going 14 and this one's going 10 mile an hour, so 14 and 10 mile an hour, so one's going to go faster than the other. Obviously, because they're accelerated up to that speed, they are both going to travel, you know, different distances. So you could say that one's, you know,
well, your theory is they're going to travel the same distance, so that's your theory. So even though one of them's twice as light and it's going faster, you're saying it's going to travel the same distance because it has the same energy.
One's going to be a smaller distance. So again, if we were looking at that, we're going to think, well, yeah, you know, this one's going faster and it's going further. This one's going slower and a shorter distance. So that doesn't really tell us a lot.
You're saying friction is linear. You're saying it doesn't matter how heavy it is and it doesn't matter how fast it's going. That's your argument. That it's the same amount of energy pulled out per foot. So if you gave them the same kinetic energy going in, they should be losing the same amount of kinetic energy per foot, because you don't think gravity changes that equation, makes it nonlinear. So my argument is it's not linear, okay, and that experiment's not going to produce the same distance.
Aren't really, you know, compare that as such, as it doesn't shout anything out at you. You know, it's clearly different, obviously, because of different masses, and you apply a different amount of energy to them. The same amount of energy to them. They're going to react differently. You know,
no. That's the whole argument. Is that they're not supposed to. You're saying it's linear. That means they lose the same amount. So you're conceding that if it's heavier, it's losing more energy to the ground per inch. You're conceding that argument, correct? And now, so all we have to do is get rid of this 2 kilograms and make it 4 kilograms, and then say, what happens if I double the velocity? I quadruple the energy of one of the objects by making it go twice as fast. I've given it 4 times the energy. Now, the argument is, okay, simply put, what's going to be the outcome in terms of recognizing what the implications of that is in terms of its movement. And you're again now going to be stuck with the fact that you've already conceded weight matters. So you've conceded half the argument. Now the only other argument to concede is that velocity matters.
Go faster and further. But what we do know in terms of friction is that, you know, when you launch an object, when you give it motion, they're going to wind down to friction over time. You know, as it runs along over time.
Alright, so the only thing you need to explain in this video was, why do you believe it doesn't matter whether how heavy it is or how fast it's moving? Because both of those are decided by gravity. How heavy it is, how much it weighs, is decided by gravity. How much speed or time matters in terms of how much time it spends on a surface clearly is dependent on gravity again. Weight is a function of time. If you don't spend enough time on the scale, you can't weigh your weight.
You know, it's going to lose its energy to friction. So in both cases, what we need to look for is the time. How long does it take in terms of time for each object from its launch to its coming to a standstill,
We already
how long does it take?
that's already calculated. So we know that when the object goes 4 times the distance, it only takes twice the time. So that's already, you should be able to concede that argument.
And that'll give us a good indication, because we know they've got the same energy in. So obviously if we see discrepancies at the time, one's vastly shorter than the other, then clearly the energy is being sapped out at a different rate. So right, I think it'd be good to launch the heavy mass first, compress the spring, launch it, and take note from the moment it's launched to the moment it gives up all its energy, how long that takes, how long the time takes. So we launch the heavy mass, the 4 kilogram, and see how long it takes to wind down.
So again, all of this has already been done by just dropping the object. So already you know the relationship. 4 times the distance is only twice the time. It's a fact. I'd say it's twice the weight. Okay, I say that's also a fact. And it's only twice the velocity. Fact.
Friction. We'll do a couple of trials, well, maybe 3 or 4 trials of that, and then obviously we'll reduce the weight. So again, same part, same low friction, same surface, same everything. Reduce the weight, launch it with the same spring, same amount of energy, and then obviously make notes of the time it takes for that part to wind down to friction. And then we look at the differences between the two, because we've got the same energy in. Obviously we would expect the same energy out.
So yeah, there's really no point in us talking about spring experiments, right? I mean, obviously, you don't know how to get the energy out of a spring consistently. Obviously, a spring's moving twice as fast. It's a substantial difference in its function than when it's moving half that speed. And so you can't have a bunch of rickety, I'm going to let go of it with my fingers, or I'm going to do this, or you have to be very careful how you allow the energy from the spring to go into the object, because the faster it's putting the object in, the more delicate, in the sense that you can lose a lot of energy with just a tiny bit of vibration. So you have to make sure you're not making any mistakes in imposing the spring's energy into the object. There's a difference between hitting and pushing. I mean, all these arguments I've already made. Blah, 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 blah.
But if this is incurring more friction, or this is incurring less friction, however you want to say it, then there should be some, not saying significant, but there should be some discernible, difference in time. That's, out of the trial, say we do 4 of this one and 4 of this one, we should be seeing consistently lower times for the heavier mass and longer times for the lighter mass. So that's what we should see.
Yes, the faster it goes, the less friction. The lighter it is, the less friction, is the simple argument. I think that'll be proven in any experiment you do where you change velocities and speeds, that you'll find that there's less friction. So, and ideally it'd be at best if you could just measure at the absolute truth. That is, you could just measure the temperature, say, of the surface that's collecting the energy, taking it from the object. That would be the ideal. But time will tell, in the sense that the thing who's getting who's losing less per foot is going to travel further.
What you're saying is true, but again, you're making a claim, we can't test these things, and that's what I'm proposing, that we test this out and see how these things function, rather than just while I'm drawing a picture here and you're very good at drawing pictures too, I'm actually going to move to some experimental setup to bolster what I'm not claiming anything here, I'm just showing the evidence. Luckily,
well, let's see it. Okay, but again, I'm sorry, but I have no confidence in your capacity to do spring experiments with the necessary caution and care, required to do them right, to not cheat the experiment by having way too many variables that you haven't accounted for. Play.
This experiment's already been done by Stephen Brough around about 9 months ago, so I don't have to go to the...
So again, I'm not going to take any of that on its face value. I can just say Stephen Brough also did the catapult experiment and got results of 19 to 1. So I mean to 11. So clearly 2 to 1 relationship. So their argument over. We're done. I mean, it's just bullshit. If that's how you want to argue from crap experiments that you're not even going to show, fuck you is my response to that.
Trouble of actually constructing it and building it and executing it, because Steve did a fantastic job of that already. He did a very, very thoughtful.
It's retarded. The premise is all wrong. All he did was use a rotten plastic spring device and claim he's getting all the energy into the objects. Just his claim, no proof that the spring device works, no proof that it works at the higher speeds, no proof that the parts aren't consuming all of the energy. When the faster it moves, the more the parts create friction and lose more and more of its energy. No evidence whatsoever. Fuck you. This is just... you're just a propagandist to be sitting there and claiming Stephen Brough has done foundational physics experiments with any kind of scientific credibility. Oh, please. That's just such a reach. You're going to rely on a Stephen Brough experiment to prove a physics fact. Come on.
Plan on it, obviously did a really good construction and executed it very well. So with his permission, I've edited some of the footage from that video. As I've said previously, what we're looking for is the time. So we're going to launch, we're going to show the heavy map.
All right, so I'll just do the same thing for, synthetically. Let's just use our imagination. I'll just take the clips of Stephen Brough's billiard experiment, 19 to 11 results. You watch the half mass going at, preposterously fast speed, way the fuck more than 0.4 faster. Clearly the spring produced much more than 0.4 velocity increase. So fuck you in this bullshit. This quote mining brozo experiments.
4 kilogram mass being launched first. We've got to make note of the time it takes from the moment it's launched to the moment it comes to a standstill. That's the time we're looking for. And then obviously the weights, the 2 kilograms will be taken out, so it's now half the weight, released with the same energy, moving at 1.4 times the speed. So it is faster, it's lighter. That seems to be your claim. Faster, lighter objects incur less friction or...
Yeah, and where are you proving this? I'm sorry, Brozo never did an experiment proving any of this. You're out of your mind.
So vice versa, heavier masses incur more friction. So again, when we launch 2 kilogram, again it's going to go faster, it's going to go further. In Steve's experiment, obviously, because he's launching this thing, and obviously doesn't have loads of room, so it makes sense just to launch it from one wall to another wall and just bounce it back and forth. We know springs conserve energy, so there's a spring on each end of the cart. Yes, it is going to hit, change direction, so on and so on, but each time it does that, the springs are very good at storing energy and returning energy. One of man's greatest inventions in that respect. So yeah, each cart's going to be launched, bounce back.
So there's really no point in this. It's exactly the same experiment. He's saying that, okay, if I give it twice the velocity, it goes 4 times the distance. It's the same experiment. I'm not disputing that the thing with twice the velocity goes 4 times as fast. I'm disputing that the friction is linear. Well, where did you miss the argument? Oh, you certainly did miss it. So if we go by time, we time how long it takes it to do the bouncing, okay, you'll find that it's the same amount of time for the slow mass to wind down as it was for 1/4, okay, of that time is the only time that the fast mass is doing exactly the same thing. It reaches half the velocity, 3/4, of the bounces, the number of bounces, is where it's going half the velocity. Not half the number of bounces, 3/4 of the number of bounces. Useless.
Bounce, and eventually it will come to a stop, it will wind down to friction. Both cards will do that. And all we're interested in is the time, because we know the inputted energy is the same. So if the energy is being drawn out at a different rate dependent on its weight and its velocity, then we would expect to see, like I say, not necessarily significant, but if we do 4 trials of each, we're looking for a consistent difference in time, and that will.
That's the whole point. The time is only twice the time. 4 times the distance, and it only takes twice the time. So what are you even talking about? I don't know. Play.
Let us know what's going on and whether your claim is true. So the footage I will be showing is courtesy of Stephen Brough, who did a fantastic job. This video that he did actually was very underrated, very overlooked. Obviously he demonstrated the 1.4 thing very well.
Well, let's see that part. Yeah, let's see the 1.4 thing.
Which clearly you don't accept, but there it is. That's the facts, whether you like it or not.
So again, yes, this is this proves it. Stephen Brough experiment.
You're probably not going to like this fact as well when we show the footage and you see the results, but energy is not momentum.
It says you, with no evidence. So by your theory, it takes 25 times the fuel to go 5 times faster. And if I make something go 5 times faster, I just increase its velocity by 5 times, it'll do 25 times the damage. It'll move 25 times more atoms. Will fly off at 25 times the momentum. No. So we're back to no quick release. Let's just understand. So he's just pushing a spring all the way, compressing it to the complete maximum, which none of these things you're supposed to do that. All right, so this cart is weighted. I don't know what it says there. Let's see. I don't know. It says 4 kilograms. I can't even read it. So this is the heavier cart, twice the mass. Going a lot slower. And this is the lighter cart. So we're to believe that the lighter cart is so much slower. Even though it's lighter, it moved with less velocity. So there's 2 sources killing the motion, right? You got the first is the friction with the wheels, and you've got their angular momentum. So it's wearing it down, and then we have the springs that lose energy.
So now we're going to do the half the mass. It's going to 1.4 times faster.
So that's, you say so. It's 1.4 times faster because it took 1.4 times the time. That doesn't make any sense. That's not the rule. That's not velocity.
Speed-wise, the 4 kilogram run was roughly 24 and a bit seconds. So if we're saying that this lighter, faster cart has some advantage in terms of not having its energy drawn out over friction.
I don't know why I couldn't
could
you couldn't just write it down, you fuckhead. Just write the 4 kilograms took how long? I'm supposed to pay attention to this stupid Brozo bullshit. So this is the first cart. Launch 3. So whatever this is, launch 3. This is the 2 kilograms. It says right there on it, 2 kilograms. That's not the one I want.
Sure.
Alright. 2. I thought he did the 4 first. What's this one say? 2 kilograms. Where's the... So this other one's the 4 here? No, that's 2 kilograms. What the fuck is this? They're both 2 kilograms. There's no other... Alright, oh, I'm sorry. I'll play it again for myself and just see what the fuck are you talking about? Alright, well, I can't make much sense out of what he's showing. Both carts say weighted plus 2 kilograms. That's what this cart says, right? Now the other one says... this really shouldn't be an issue, but weighted plus 2 kilograms. So it is the weight of the cart plus 2 kilograms. So both examples are the same example. And it looks like the same weight. So both he's showing us are 2 of exactly the same experiment. I don't understand. Sorry. I don't have any clue what you're talking about here. They're both the same weight. Alright, so that was a waste of time. Yeah. Okay. So we'll go back to wherever the fuck he was, whatever the fuck he's arguing. I have no idea what he's arguing.
4 and a bit seconds. So if we're saying that this lighter, faster part has some advantage in terms of not only having to drawn out over friction, we could expect it to run for a longer time. So if the 4 kilogram cart was running for 24 and a bit seconds, I don't know, I mean, it's going 1.4 times faster, so do we say this run time is going to be 1.4 times longer? Obviously it's half the weight as well, so
he never proved how fast it was going, so I don't know why he's saying it's 1.4 faster. So the whole total trip he's saying is 1.4 faster. So it's like saying I gave it twice the velocity and it takes twice the time. Okay, that fits.
So that gives it an advantage. So we should be seeing a run time. If its energy isn't being drawn out through friction because it's somehow because of its speed, it's getting a free ride to some degree. Then again, we should.
So now he's going to do the 4 kilogram. I get it. Okay, so he's just doing this bullshit. I don't know what this bullshit's for. So he says it takes 24 seconds. All right. So with 2 kilograms, it's 24 seconds.
We'd expect to see a longer run time. I think if we times this by 1.4, I don't know, would it be in the region of like 32, 33 seconds maybe, I don't know, off the top of my head. So, if it's going 1.4 times faster and that's its advantage, then, we should be looking at a run time around this mark. So, we'll run the test and see.
And if it's going twice as fast, we should see a run time that's twice as fast. Okay. So this is a lighter cart, presumably going faster, and so it'll roll much further. Now, I don't see any sign on the cart. I don't see any absence of weight. I don't see any addition of weight. So how do I know what the weight of the cart is in this one? Guess we don't know. So it looks exactly the same as the other one. So I just say for the sake of argument, I don't understand, where's the weight? Where's the extra 2 kilograms he put on the cart? This is a 2 kilogram cart. I didn't see any other weights on the 4 kilogram cart. So where's the example? Where's the evidence of that? And again, I don't. How does this prove the existence of kinetic energy? I just don't get it. Sorry. I don't know why you're repeating the same thing over and over again. What's the point? So this cart looks the same as the other cart. I don't see any difference in this cart and this cart, except Stephen Bro says so or something. So the piece of paper weighs 4 kilograms? Is that the argument? Looks like the same cart, so I'm just so where do I see the weights? There's no weights you can see. All right, so that's his claim. So this is the claim. All right, so Brozo proved it where you can't see it anywhere. You don't see it any weight. You don't see any extra weight on the cart. There's no evidence there's extra weight on the cart. So you're saying it's twice as heavy, and there's no evidence that it's twice as heavy. Okay, fine. That's your claim. Alright, let's play it through and be done with it. So he's also, let's understand his argument, that somehow bouncing it back and forth between springs is a better way to test it than just to allow it to roll on an even surface. So obviously the springs are adding a complication to the experiment, but frankly it's still, I'd say, junk as an experiment. Half the mass you're saying has the same friction, okay, as something that weighs twice as much. And to me, it's absolute nonsense. It'll never happen in any linear experiment.
Having run the 2 kilogram cart, we can see that the times are almost identical. Like I say, somebody could probably do, maybe Dispar could actually take Steve's original footage.
Yeah. Just do frame rates. Anybody could do frame rates. So somebody could do frame rates like Brozo do that, and see what the velocities are, because clearly it's not twice the velocity. Okay, so, but whatever. No one did it, right?
So I'm not able to do that. I say I've just timed off a stopwatch. Probably not the most accurate, but for the purposes of this argument or presentation, whatever you want to call it, it's pretty clear that each object, regardless of its weight, it's the velocities. What did we say? Time for that.
This is okay. So this is your argument. Okay, so this is the best evidence you can produce in 500 years. In 300 years of Leibniz's argument, this is the best you can do in terms of producing anything. It's like any kind of evidence, and it's such crappy evidence. And your argument is that weight doesn't slow objects down. That is, they don't lose more energy quickly, faster, the heavier they are when rolling on a surface. Clearly, I think that's going to be proven to be absolute nonsense in the future. So you're only staking your position as, part of the Dark Ages. You're a Dark Ager. Okay, you're wrong, and you're going to be found to be wrong, and so all this crap you've done is just going to look like what it is, which is propaganda. Because again, I think you're way too smart not to realize that friction isn't linear.
What's in for that? So regardless of its weight and speed, the amount of energy going into both equals the same run time for both. Same time, same energy, yeah.
Alright, so let's understand. Same energy in the billiard ball experiment. Same spring compression. One of the billiard balls leaves with, uses only 11 frames to get from to a location. The other one uses 19 frames. Clearly very close to 2 to 1. There. Proven 1.4 is a nonsense. So debunk that video.
The same energy.
Prove Brozo wrong. Prove that experiment was wrong.
That's no more, no less. So obviously the energy of this lighter, faster one is not getting a free ride, and the heavier, slower one isn't incurring more friction. You know, the same energy is going into both, and the same energy is coming out. So friction's obviously being drawn out.
Right. So again, you just roll the object. So the springs are obviously what's creating that. So the springs are equaling the friction. The springs aren't gravitationally dependent. The springs aren't doing the 1, 3, 5 thing. Okay, so if the springs are what's taking the energy out, that is the inefficiency of the springs, then yes, the friction is going to be linear because the springs are taking the energy in the same amount for each compression. So you're not really proving the point. You're just adding another complication to a simple experiment. So that would be my simple explanation for why you'd get anything close to the same result. But I'm clearly going to argue it started off way wrong in the sense that Brozo, because he doesn't know much about how springs work, overcompressed the spring. So the 2 mass never got twice the velocity. It never got what it earned. Never got the same momentum. It certainly wasn't going twice the velocity, which is directly what I claim in my video. Give something twice the velocity, it goes 4 times the distance.
That's a linear rate. Like I said, I will leave a link to Stephen's original footage of the video. I'd say it's worth a view, very worth a view. It's a really good video, really good demonstration.
So it's really not a good demonstration of Galilean physics because of the why add a second mechanism to absorb the energy. You're trying to figure out how much the ground is taking. How is banging it into a spring going to help you determine how much energy the ground is taking? Oh, obviously it's not.
If anyone wants to do a better timing analysis, that'd be great. Like I say, I've just done it sort of a rough way, but you know, maybe if you can load it into the computer and get the frame count, you could get it down. I mean, I think when I was timing it, the lighter, faster mass was a tiny little bit shorter in time, but that could have been, you know, I'm talking like points of a second, but you know, that could have just been the way I'm timing it with a stopwatch. Like I say, if somebody wanted this far, you know, or somebody else wanted to analyse it, that'd be great, because it'd be interesting to know the exact, you know, times per run.
And again, the times per run are going to be completely dependent on whether it's going twice as fast or not. If it's not going twice as fast, you don't have the expectation it's going to go 4 times the distance. But again, you can't really undo how many times it bounces back and forth. So count how many times it hits a spring, and that'll tell you how much energy it's losing.
But you know, all in all, it's a pretty damn close thing. You know, the faster lighter one and the slower, heavier one.
All right, so I don't know, his argument is what? You know, so again, there's a simple experiment done many times where you roll something down a surface and you can see the outcome, okay? And the point is what does the outcome show you? Does it show you how much energy it has, or is it just showing you how friction isn't linear? That's the simple argument. And I'm saying that the obvious choice is it's showing that friction isn't linear. It's showing what you know to be true, and frankly, you know it. I mean, you just can't. You really think it doesn't matter how fast I move something across the scale, it's going to feel the same amount of pressure, no matter how long the weight is on top of the scale. It's the same amount of energy, regardless of how long it's on the scale. I mean, you've got to know that's absolute crap.
Given the same energy in both cases equals pretty much the same energy on the way out. Friction for this one doesn't differ for this one.
So it's clearly not tested in that experiment, but anyway, fine. It's a response. I mean, it's garbage. It's, frankly, I don't think you're on the subject. It's not the experiment I'll do to test it. Frankly, the experiment needs to be done is where's it going half its speed? That's going to tell the tale. Because it's just kind of obvious that the one object's doing exactly what the other object did, and its whole travel is going to happen in the last quarter of the other object's life. The last quarter of its life going to be exactly like the full life of the other object. So it's going to be going half the speed at 3/4 the distance. It's going to be doing what the other object did. Okay, the thing going half the speed, it's going to do exactly what it did in the last quarter. Just like in gravity. Not linear.
You shouldn't. There's frictional there. Yes, it appears to be.
Alright. So again, I can't believe that people really are arguing this. I mean, it just seems they really don't think gravity is a time-dependent force. They really
I've
don't.
gotten a ton of requests on this. Today we're going to be looking at another one of Cyber Pirates that,
Fuck you, cunt. I mean, I keep turning this autoplay off and it keeps putting it back on. Fucking YouTube. Anyway, so I mean, there's a simple bent geodesic, whatever it is, it's motion. You can't get the fact that the gravity is causing motion and it's happening constantly. Every millisecond it's pushing. And that the amount of time it's being pushed is completely going to decide how much energy it can absorb. There's no other way to absorb the energy than time. You have to be falling a certain amount of time to acquire a velocity. The time in the gravity free falling will decide. The distance doesn't matter. I mean, I drew the whole idea of flying through gravity. And the faster you go through it, the less gravity is going to push you. It's just a fact. I mean, how can you deny that fact? I just don't understand how, all right, so, okay, you did this video, and maybe the simpler video, I just do a video dedicated to the one gravity argument where I draw the gravitational circle and you're going to fly by a certain amount of distance. And all that's going to matter is how fast you go across that distance. The distance isn't telling you anything. The speed, the amount of time you're going to be in the gravity is all that's going to decide how much the gravity pushes you. Come on. And the same is true for flying, horizontally. Time tells. And everything's going to fall at exactly the same amount of time. Because there's nothing resisting that motion. Distance won't matter. Oh, people are so stupid. Okay, so, I just can't believe that this is hard for them to understand. It's a very good theory, okay? There's not a single thing you can really say to refute that gravity is a time-dependent force. That's about how much time you are being influenced by it. If I'm holding you, you're not being influenced. If I'm applying friction to you, you're not being influenced. When you're a free body in space, it's going to be about how much time gravity has to push you. That's how fast you're going to go. Alright, anyway. Too stupid. Till the next time and such. So at least it's a better effort. But again, he played my video and didn't even answer the points. Okay, they weren't even relevant. He's talking about how you push the objects rather than the fact that no, the objects already have velocity. We're establishing that as a fact. He couldn't even get that part right. So anyway, I apologize for the hour video. It really shouldn't have taken that long. But these videos are so hard to watch that I really hate watching them twice. Just hate the idea of doing it.